Hey guys, welcome back. Today we are going to learn the fifth way that we can prove triangles congruent. So it's the fifth shortcut. In our previous lesson we learned four shortcuts. We learned side, 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 angle, side, angle, side, angle, and angle, angle, side. Today we're going to add the fifth shortcut. There are only five, so this will be the last one, and the last one is hypotenuse leg, HL. But before we learn how to use HL, let's learn what HL actually means. The L is the legs of a right triangle. The legs of a right triangle are the two sides of a right triangle that are adjacent to the right angle. Adjacent means next to. So here is a right triangle. Here's a side adjacent to the right angle. That is a leg. Here's the other side adjacent to the right angle. This is the other leg. The hypotenuse is the side of a right triangle opposite the right angle. So this over here across from the right angle is the hypotenuse. So now that we know what hypotenuse and leg means, what the words mean, we can use the hypotenuse leg congruence theorem, which says if the hypotenuse and a leg of a right triangle, and this only works for right triangles, are congruent to the hypotenuse and a leg of a second triangle, then the triangles are congruent. Okay, so here's an example of two triangles where hypotenuse leg could be used. Okay, so first of all, they are right triangles. So to start with, if triangle ABC and triangle DEF are right triangles, okay, then in those right triangles, you've got a hypotenuse, BC, congruent to this hypotenuse, EF. Okay, so there is your hypotenuse. And you've got a pair of congruent legs, AB and DE are congruent. So these are the legs. So you've got hypotenuse and leg of right triangles congruent. Then you can say that the two triangles, triangle ABC is congruent to triangle DEF. Okay, so if you have right triangles in which hypotenuse are congruent and a pair of legs are congruent, then the triangles are congruent. So here we're given that segments AC and EC are congruent. That's already marked for us. Segments AB and BD are perpendicular. AB and BD are perpendicular, so they form a right angle. Segments ED and BD are perpendicular, so they form a right angle. And segment AC bisects segment BD, so AC cuts BD in half. That means this right here is the midpoint, so BC and DC are congruent segments. Is there enough information to prove that triangles ABC and EDC are congruent? The answer is yes, there is enough information. Okay, explain. So we had right triangles because of the perpendicular. So I would say that perpendicular gave us right triangles. Then this segment bisector gave us congruent legs, and part of the given was the congruent hypotenuse. Okay, so I can say that triangle ABC is congruent to triangle EDC by hypotenuse leg. Here we want to determine if triangle PQR, so this one right here, is congruent to either of these other two triangles. Okay, so now we can use any of these 5 shortcuts: side, 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 angle, angle, side, angle, 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 side, or hypotenuse leg. They are now all fair game to us. Okay, so in triangle PQR, we could just count the length of PQ, 1, 2, 3. We could count the length of segment QR, 1, 2, 3, 4, 5. For segment PR, I could use the distance formula. Okay, so let's try that. So we'll do the distance formula for segment PR. So the length of PR is, and the distance formula is x minus x squared plus y minus y squared, all under a radical. So let's get some coordinates here. So for P, we're at 1, 2, 3, so -3, 1, 2, 3, 4, 5, -3, 5. At R, we are at 2, 2. Okay, so for the distance formula, x minus x is -3 minus 2 squared plus y minus y, 5 minus 2 squared, all under a square root. -3 minus 2 is -5. Squared is 25. 5 minus 2 is 3. Squared is 9. So that is the square root of 34. Okay? I don't think this one can be simplified, but even if it could, it doesn't really matter here. I just want to see if any of the other sides of either of these two triangles is also the square root of 34. Okay, so let's check this triangle here, VWR. And let's use V and W. So V is 1, 2, 3, so -3, -2. And W is 0, -3. Now, if this side turns out to be equal to 3, 5, or the square root of 34, then we'll check other sides to see if they match the others of PQR. If this one is not one of those lengths, then I know it's not congruent. Okay, so VW, the length of VW, x minus x, -3 minus 0 squared, plus y minus y, -2 minus -3 squared, all under a square root. -3 minus 0 is -3, squared is 9. -2 minus -3, so that's the same as -2 plus 3, and that is 1. Squared is 1. So I have here the square root of 10. The square root of 10 is not 3, it is not 5, it is not the square root of 34. So it is not part of a congruent triangle to triangle PQR. Okay, so because this one side does not match any of these, I know this triangle is not congruent to PQR. So how about RST? So RS I can count. It's 1, 2, 3. RT, 1, 2, 3, 4, 5. Okay, so 2 of those sides match. 3 and 5 match. If this third side matches, the square root of 34, then I'll know that these two triangles are congruent. But it's diagonal, so I can't just count it, so I have to use distance formula again. So T is at 2, -3. S is at 1, 2, 3, 4, 5, 2. So for ST, I have 5 minus 2, those are my x's, squared, plus, and then y minus y is 2 minus -3, squared. 5 minus 2 is 3, squared is 9. And then 2 minus -3, that's 2 plus 3, 5. Squared is 25. And 9 plus 25 is the square root of 34. It looks like 3, 5, and square root of 34 is on both of these triangles, so these two triangles are congruent. So triangle PQR is congruent to triangle ST. RT. And one of these 5 reasons, well, it's all the sides that I checked. All 3 sets of sides are congruent. So they are congruent by side, side, side. Okay, we are going to graph triangles DFG, -2, 4, 4, 4, and -2, 2. So there's triangle DFG. And triangle LMN, -3, -3, -3. That's L. -3, +3 is M. And -1, -3 is N. Okay, now determine whether these are congruent. I'm going to do this one in a different way, probably a little bit easier. I've got a vertical and horizontal side. Vertical and horizontal lines are always perpendicular, so that's a right angle. Here's another vertical and horizontal. They are perpendicular, so that is a right angle. DG is 2 units long. DF, 1, 2, 3, 4, 5, 6 units long. LN is 2 units long. ML, 1, 2, 3, 4, 5, 6 units long. So I've got a pair of congruent sides here and a pair of congruent sides here, and the included angle, the angle between them, are congruent. I'm going to say that these are congruent by side, angle, side. 2 sets of congruent sides and the included angle. Okay, so I will say triangle DFG is congruent to triangle LMN by side, angle, side. Okay, now on the back page, we've got a whole bunch of triangles, and we want to know if they are congruent, so we're going to use the information we're given to determine if they're congruent or not. If they are, we're going to write a congruent statement and give a reason. The possible reasons are side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. So these 2 triangles here. So I've got this triangle has a 60 and a 90. This other triangle has a 60 and a 90. That's 2 congruent angles, and they share a side. So TW, by the reflexive property, I can say is congruent to itself. So I've got 2 angles and a side that is not between the 2 angles, a non-included side. That is angle, angle, side. So triangle STW is congruent to triangle VWT by angle, angle, side. Here I have AB is congruent to segment CB. Segment BD bisects segment AC. So AC is bisected, it is cut in half. So I've got a pair of congruent sides here. They share side BD. By the reflexive property, it is congruent to itself. I have all 3 sets of sides congruent, so triangle ABD is congruent to triangle CBD by side, side, side. XW and XY are congruent segments. XZ and WY are perpendicular segments, so these are right angles. And they share a side. So by the reflexive property, XZ is congruent to itself. So I have right triangles, hypotenuse congruent, and a leg congruent. Now, I can't use any of these other 4 because I do have 2 sides and an angle, two sides and an angle shows up right here, side, angle, side, but the angle has to be between the two sides, and it's not. But they are right triangles, hypotenuse congruent, leg congruent, so the two triangles are congruent. Triangle WXZ is congruent to triangle YXZ by hypotenuse leg. Okay, here I'm given these right angles, another pair of congruent angles, and a side between them that is congruent. So I've got a pair of congruent angles, another pair of congruent angles, and the included side angle, side angle. So triangle STW is congruent to triangle VWT by angle, side, angle. Here I've got a set of congruent sides, another set of congruent sides. I don't know anything about the third sides. These are not vertical angles. There's no more information that I can get out of these two triangles. Side to side is not enough. I'm going to have to say that the two triangles are not congruent. So not congruent triangles. Here, point C is the midpoint of AE. It really doesn't look like C is in the middle of AE, but it says it is, so AC and EC must be congruent. C is also the midpoint of BD, so BC and BD must be congruent. Again, it doesn't look like C is really in the middle, so it's clearly not drawn to scale, but if it says it's the midpoint, it's the midpoint. Then we have these vertical angles. They are congruent to each other. I've got two sides and the included angle. Side, angle, side. Triangle ABC is congruent to triangle ECD, or EDC, triangle EDC, by side, angle, side. And last, AB and AD are congruent. C is the midpoint of BD, so BD is cut in half. And AC is perpendicular to BD. Now there's actually two reasons I could give for this one. Okay, so let's go with what information is already here. I've got right angles, so these are right triangles. I've got a hypotenuse and a leg. So triangle ABC is congruent to triangle ADC by hypotenuse leg. Okay, now I could also have said that because they share side AC, that AC is congruent to itself, and then I would have side, side, side. Or because I know these are congruent, I could have had side, angle, side. So there's actually multiple ways that I could have done this one.